Would we say -2? So you're saying one of these it wouldn't let you type in? Okay. So before I put the others in here, y'all can see, like, if I turn this one off, you can see the red underneath it. So you can see that these two are equivalent, the two that we came up with. But if I try to put in, like, answer choice A would have been the 1/100 times the log of x. And then B would have been the log of x minus 2. And D would have been log of x plus 100. Are you talking about this green one? So I think it's because we're just so zoomed out. If you zoom way in, then you can see the curve of it. But it's just because it's so small, such small values, that when you're zoomed out to see the other graphs, it looks angular. Okay, let me get rid of the shift ones so we can look at just those. Oh, you're talking about the one that was not one of the answer choices. I'll put that in and let you see. So that is the multiplying by the 100. So let me get a different color because it. Yeah. So the difference here is, so this one is the horizontal stretch that we're talking about. Okay. And then this one is the vertical stretch. And then this one is the vertical compression. Yes. Here, I'll add the other, so this would be log of 100 times x. So we can see all, I mean, because this one is, you can see the green one. Let me change the color on this one. Make that purple, I guess. Let me. Okay, so the red and orange, those are both in the number, the 100 is inside the log. It's part of what you're taking the log of. So that is a horizontal stretch or compression. This one is a horizontal compression. And this one is a horizontal stretch. When it's on the outside, it's a vertical, and it's, if it's greater than 1, it's a stretch. If it's less than 1, it's a compression. So this one was being compressed by 100 vertically. This one's being stretched by 100 vertically. The orange one is being compressed by 100 horizontally, and the red one is being stretched by 100 horizontally. Yeah, because if you think about it, if it's affecting the x, it's inside. So if you're affecting your x value, that's your horizontal axis. So if you're inside, you're affecting the x value, so it's a horizontal transformation. If it's on the outside of the function, what that's affecting is the y value, which the y-axis is vertical. So anything on the outside of the function is vertically transforming the graph. If it was outside being added or subtracted, it's vertical shift. If it's inside being added or subtracted, so anything inside is a horizontal change. Anything outside is a vertical change. Same thing with the negative. If you multiply by a negative on the outside, you're affecting the y value, which means if I change my y value from positive to negative, I'm reflecting over the x-axis. But if I put my negative inside, I'm affecting the x value. I'm changing x from positive to negative, so I'm reflecting over the y. So no matter if it's a negative for a reflection or being multiplied for a stretch or compression or being added or subtracted for a shift, if it's inside, it's horizontally affecting the x, and if it's outside, it's vertically affecting the y. And you can go in and you can play with different numbers and play in Desmos. That's a good one so you can get a visual. But like that one looks really weird, the green one. And that's just because we're so zoomed out because we're using such large numbers. Like it might be easier to see like if we used the 2 instead of 100. We'd be able to see those a little better. So now you can kind of see them all. Oops, I accidentally took off the L of my log. There we go. So now you can see those all as the curve and how they're affected. And you could even put the parent function in here as a reference. You make that one black. So you can see the black one there and how each of those affected it. Okay, so I don't know. I hope maybe that visual or seeing that helps. Okay, so we only had, so that's just the front. We'll talk about the back Wednesday. That's fine. We had an extra practice day built in anyway because we cut the quiz, so we'll be all right to talk about that. But there is an Alex assignment going over your logs and exponential equations and solving. If this side right here at the very top is the notes there, and so you might be able to just read that and refresh on one-to-one property from last year.
This file.
Hang on 1 sec. Let me stop this recording.